When the interstellar comet 3I Atlas streaked past Earth, NASA prepared for silence. Instead, every telescope lit up with data that defied explanation. Violent jets, alien chemistry, and a double tail that shimmered like a living thing. In moments, a faint blur became a cosmic revelation. What scientists discovered changed everything they thought they knew about comets, interstellar travel, and a mysterious bridge of matter connecting our sun to the stars beyond. A stranger in the sky. It began quietly one evening, when a survey telescope in Hawaii detected a faint, fast-moving point of light that didn't match any known asteroid path. Within hours, orbital solutions revealed something extraordinary, a hyperbolic trajectory with an eccentricity greater than 1.2. That single number meant this object wasn't bound to the sun. It was an interstellar visitor. Astronomers named it 3I Atlas, marking it as only the third known interstellar object after 1I Oumuamua and 2I Borisov. From the start, 3I Atlas defied expectations. It was racing through the inner solar system at nearly 58 km/s, following an 85-degree retrograde path, cutting across planetary orbits rather than traveling within them. Archival images later revealed it had already been active long before discovery, with a faint coma visible when it was still over 6 astronomical units from the Sun, farther than Jupiter. That early activity meant this wasn't a lifeless rock. It was a true comet, already warming and venting gases in deep space. Spectroscopic analysis confirmed its alien nature. Observations from Hubble Lowell Observatory and the James Webb Space Telescope showed a coma dominated by carbon dioxide, CO2, containing smaller amounts of water vapor and carbon monoxide, CO. The CO2 to H2O ratio, roughly 8.1, was unlike anything seen in local comets. This ratio implied that 3I Atlas had formed in a much colder environment, perhaps near the outer edges of a distant star's disk, where carbon dioxide freezes before water does. Every molecule detected carried a chemical signature from another world. By the time it neared Mars, the object had become one of the most studied comets in history. Ground-based telescopes, space observatories, and even interplanetary spacecraft began coordinating observations. This was a once-in-a-generation event, a comet from another star system passing close enough to examine with modern instruments. But no one could have predicted what would happen next. As the visitor began to interact with sunlight in ways that stunned NASA and the entire astronomical community, it came to its closest brush with a planet, a near pass by Mars, offering a unique vantage point unlike anything seen before. Spacecraft orbiting Mars were redirected to observe the fast-moving object, capturing data that Earth-based telescopes couldn't. What followed was a moment of cosmic choreography. Multiple missions, multiple instruments, all focused on a single visitor from another star. And as the data began to arrive, scientists realized they were witnessing something truly unprecedented: the Mars flyby. When 3I Atlas passed Mars, it came within about 29 million kilometers, roughly 0.19 astronomical units, a cosmic near miss on an interplanetary scale. Traveling at more than 32 kilometers per second, it flashed through the Martian system in a matter of hours. The Mars Reconnaissance Orbiter, MRO, turned its powerful high-rise camera skyward, pushing its limits to image the faint, dusty coma at roughly 30 kilometers per pixel. For a spacecraft designed to study the Martian surface, this was an audacious experiment. At the same time, the ExoMars Trace Gas Orbiter, TGO, and Mars Express reprogrammed their spectrometers to capture potential gas emissions. Their instruments scanned the skies for signatures of carbon dioxide, carbon monoxide, and water vapor. Even the Perseverance rover joined the effort from Jezero Crater. Its Mastcam-Z cameras took long-exposure images of the Martian sky, later revealing through careful stacking a faint blur where 3I Atlas was predicted to appear. A comet from another star had been seen from the surface of another planet. The flyby revealed something extraordinary. Because Mars viewed the comet from a different angle than Earth, its instruments saw the coma in forward scatter, where sunlight passes through the gas before reaching the observer. This geometry amplified faint features invisible from Earth. Dust grains smaller than 10 microns reflected light like fog, while larger compact grains polarized it. Even at that distance, scientists could tell that 3i Atlas's dust was unusually large and reflective, a clue to its dense alien composition. When the data reached NASA's Jet Propulsion Laboratory and ESA's Mission Center in Darmstadt, it became clear that history had been made. For the first time, an interstellar object had been studied simultaneously from multiple planets and spacecraft. Within those blurred frames and spectral lines lay a chemical and structural fingerprint from a world that had never known our sun. Humanity had turned Mars into a cosmic listening post, and 3i Atlas was telling its story across light years of silence. But the story didn't end at Mars. As the comet sped toward the inner solar system, it began to change dramatically. Its brightness surged, its tail twisted, and its chemical makeup shifted in ways no one had anticipated. What scientists thought would be a quiet passage turned into an unfolding drama. For the first time, researchers could watch an interstellar body wake up, and what they saw in those following days would challenge everything they thought they knew about comets. In the days after passing Mars, 3i Atlas erupted into activity. Its brightness climbed by nearly 1.5 magnitudes within just 2 days, a surge faster than most solar system comets ever display. Spectrometers began detecting strong emissions of carbon monoxide, CO, and carbon dioxide, CO2, around 4.3 to 4.7 microns, evidence that deep subsurface ices were suddenly exposed to sunlight. The comet wasn't fading into calm. It was waking up. The James Webb Space Telescope, using its NIRSpec and MIRI instruments, recorded rapid fluctuations in thermal output. Surface temperatures oscillated between 110 and 160 Kelvin, spiking in response to bursts of sublimation. Scientists theorized that trapped gases sealed beneath dusty crusts were breaking free under internal pressure. Each outburst propelled jets of dust at speeds exceeding 100 ms, shaping the comet's tail into sharp, uneven fans. Even from tens of millions of kilometers away, Webb captured the signs of violent transformation. Ground-based telescopes, including the Very Large Telescope, (DOVLT), and Keck Observatory, confirmed the visual spectacle. The comet's tail split into 2 distinct branches, one glowing faint blue from ionized gas and another shimmering yellow-white from sunlight scattered by dust. Polarization measurements revealed differences in particle composition, while the separation angle between the tails grew wider over time. It was as though the comet were unraveling, exposing the physical contrast between its chemical layers for the first time in human history. For NASA's scientists, this transformation carried deeper meaning. The changing jets, asymmetric tails, and chemical diversity all pointed to a complex, layered structure, possibly a cluster of fragments bound together rather than a single solid core. 3i Atlas was teaching them that interstellar comets are not simple icy relics, but dynamic evolving systems, alien machines powered by sunlight and chemistry. What began as a faint dot in a telescope had become a living experiment, rewriting the boundaries between physics and astronomy. With each passing day, the revelations multiplied. The comet's coma expanded to more than 100,000 kilometers across, and the ratio of gases within it shifted unpredictably. New compounds appeared, hinting at chemical reactions unseen in ordinary comets. For astronomers watching from Earth and orbit, one truth became undeniable. 3i Atlas wasn't a frozen relic from another star. It was a message, alive with motion and complexity, whispering that the universe beyond our sun may be far more active than we ever imagined. The physics of its fury. In the wake of its surge in brightness, 3i Atlas revealed a level of physical activity few had anticipated. Data from the James Webb Space Telescope showed continuous variations in heat and light, implying that the comet's rotation and outgassing were tightly linked. The measured velocity of its ejected gases exceeded 400 ms, strong enough to impart measurable thrust. Over time, even these minute forces altered its orbit slightly, by about 2x10⁶ astronomical units per day, confirming that gas release was reshaping its trajectory. Astronomers studying the thermal behavior of its nucleus noted temperature changes between 110 and 170 Kelvin, swinging over cycles of roughly 9 hours, likely corresponding to its rotation period. As one hemisphere faced the sun, subsurface gases expanded, fracturing the dusty crust. As it rotated away, they refroze. This constant cycle of heating and cooling created mechanical stress capable of cracking ice layers several meters deep. The result was a sequence of jets that erupted in pulses, releasing both dust and vapor into the expanding coma. The kinetic energy behind each outburst was staggering. Even a small jet venting at 50 kilograms per second would unleash energy equivalent to thousands of tons of TNT over just a few hours. Observers compared it to a frozen volcano, an ice world venting in space. These outgassing events were recorded not just as flashes of brightness, but as measurable motion. Using photometric tracking, scientists saw slight shifts in the comet's spin, evidence that asymmetric jetting was pushing against the nucleus like a thruster.